In this lesson, we are going to examine the process of doing a linear search on an array. Let's get started. We've got two learning goals for today. The first is that we can explain the linear search algorithm and use it to solve problems. The second is that we can use common algorithms that are based on linear search, such as finding the maximum and minimum values. The term algorithm in computer science just means that it's a recipe or a technique for solving a problem. Linear search is designed to locate an item in the array, and it's based upon a traversal that includes an if statement. Each time we visit an element, we'll check to see if it's the element that we're looking for. We'll write our linear search as a method that takes two parameters. The first parameter is the array we want to search, and the second parameter is the item that we're looking for. So, of course, this is based on a traversal. We start I at 0, we loop I all the way to the end of the array, and we have an if statement where we check each element to see if it matches what we're looking for. And if it matches what we're looking for, we'll go ahead and display the location where it was found. Let's say we wanted to use our method to search for the number 7 in an array called nums. The first thing we would do is we would call the method. We would say linear search nums, 7, and the loop would then traverse the array. And each time it visited an element, it would check to see if it's a 7. Now, eventually at index 4, it will find the 7, but the linear search will keep going and search all the way through the array. So if there were several 7s, it would find all of them. In this case, there's only one, so the output will simply be found at index 4. Let's try this again, but searching for the value 11. So we call the method linear search nums, 11, and the loop in the method would traverse the array looking for that 11, but you'll notice that there is no 11 in the array, and so it's never found, and because of that we end up with no output because we only print when the item is found. So we need a way to deal with this because it would be very helpful to know that the item wasn't found. Let's look at how to implement the not found case. The first thing we're going to do is before the search, create a Boolean variable and set it to false, and we can see that here. The purpose of the isFound variable is to know whether or not our search was successful. False will mean it was not successful, and true will mean that it was successful, that we found what we were looking for. So the second step is during the search, if the item is found, we'll change the Boolean to true. So once we succeed in our search, we'll set isFound to true. We're changing the variable to mark that we were successful. And finally, after the search, after we've looked through the entire list, we're going to check to see what the status of our variable is. And if the isFound variable is false at this point, meaning it never got changed to true, we'll be able to say that the item was not found. In the previous examples, we used a traditional for loop to perform our linear search, but we can also use an enhanced for loop. The only disadvantage is that we can't know where the item was found because enhanced for loops don't deal with index values. But you can see from the example here, we say for each item in the list, if the item matches what we're looking for, we can print line found. And of course, we could add the not found case here as well. I just didn't for example purposes. Another common variation of linear search is to have the method return the location where the item was found. So previously we had a void method, now we're returning an int, and when the search is successful, we're returning the I variable, which is the index where we found the item. Keep in mind though that because we return from the method as soon as our search is successful, this will only find the first occurrence of the item we're looking for. In the end, if the item isn't found, we can return -1 as a way to signal that the search was not successful. This may remind you of the string method index of, because the index of method works this exact same way. Finding the largest or smallest element in an array is a really common computer science problem, and solving it really just requires a few modifications to the linear search algorithm. The first step is that we're going to create a variable to store the minimum number in the array. And we're going to start out by setting it to a very large number. In other words, we're going to assume that the min value is actually huge. And then what we'll do is we're going to traverse the array. And every time we find a number that's smaller than min value, we are going to replace min value. So right away we find a 2, and 2 is clearly smaller than this huge number, so min value changes to a 2. The traversal continues, and we encounter a 5, but 5 is not smaller than 2, so we move on. And by the third time through the loop, we find a 1. Now, 1 is smaller than 2, so we're going to update our min value to be 1. We go to 0. 0 is also smaller than our min value of 1, so we update it again. We go to the 7. 7 is not smaller than the 0 we already have. We go to 9. 9 is not smaller than the 0 we already have. Here's the code we need to write for getting the minimum value. So notice that our method returns an integer. It's called getMinValue, and we will send it the array. So just like we saw on the previous slide, we set the minimum value to a very large number, and we traverse. And each time the element in our list is smaller than the minimum value, we update the minimum value. In the end, we return the minimum value. For today's understanding check, I have a couple of questions for you to consider, though I'm not going to necessarily give you answers to them right now because you're going to explore the answers in the exercises for this lesson. The first question is, how would the code for linear search be different if we were searching through an array of strings instead of ints? The second question is, we looked at how to find the minimum value in an array, but how could we modify that to find the maximum value? Think about these things, and if you do, it'll help you with the exercises for this lesson. At this point, you should be able to explain the linear search algorithm and use it to solve problems. You should also be able to use common algorithms that are based on linear search, such as finding the maximum and minimum values.